Hello everyone, my name is Alex Yang. I'm a fourth year civil engineering student at UCI specializing in water resources. Today I'll be talking about remediation issue for water and by correlation soil, as well as solutions to solving the issue that is PFAS. Per and polyfluoroalkyl substances, more popularly known for a shortened name, PFAS, are defined by the Agency for Toxic Substances and Disease Registry, ASTDR, under the Center for Disease Control as man-made substances that have been widely used for its durable properties that have proven results in firefighting foams to put out fires for the military and non-stick consumer products for the general public. However, PFAS are so durable that they do not dissociate naturally into the environment and cause immune problems and cancer with enough exposure. This is a problem that has been discovered very recently because PFAS are extremely small particles that have only been detected after decades of accumulation. A large number of wells supplying water to the general public within Orange County region have been shut down due to the detection of PFAS in recent years. I'll be discussing a few solutions to the reducing PFAS transportation into the environment and consequently reducing exposure to wildlife and human beings. First, I would like to define what remediation is. Remediation is removing contaminants from the source. For example, if oil is dumped into a plot of soil, the processes of remediation would be to remove the contaminant, in this case the oil, from the source, the soil. There are many different methods to performing remediation, but the best methods are ones that do not have a large impact on the environment. For example, one way to get rid of the oil in the dirt would be to dig up all the contaminated soil, transport it into a processing facility to separate the oil from the soil, and then transport the remediated soil back to be filled up to where it originally was. This method would be very costly in terms of capital and manpower. The same can be said about PFAS. Many PFAS enter the environment through wastewater discharge and storm runoff. The ASTDR states that certain items, such as grease-resistant paper, fast food containers and wrappers, microwave popcorn bags, pizza boxes, candy wrappers, paints, varnishes, and sealants, all contain PFAS. Many of us see these items on a daily basis on the ground, which can contribute to PFAS entering the environment during a storm event, where most of the storm drains directly transport the contaminated storm runoff into major bodies of water, or PFAS will be absorbed into the ground and contaminate groundwater reservoirs and the soil around it. Currently, most treatments of PFAS that are being implemented are for advanced purification systems to prevent exposure to humans through drinking water with activated carbon, ion exchange resin, and other alternative methods. However, this does not prevent or reduce exposure to the environment and the wildlife that can bioaccumulate PFAS, for example, fish. So what is preventing exposure to the environment? Nothing. For this, I propose two main solutions. The first solution is to implement more best management projects that are able to intercept storm runoff and groundwater contamination. Best management projects, otherwise known as BMPs, are physical or non-physical methods that prevent pollution of runoff. Some physical BMPs that would be suitable for combating PFAS contamination will be swales or a modular wetland system that could be modified to either incorporate some plants that absorb PFAS very well or incorporate activated carbon or ion exchange resin to filter out any PFAS. Some cons to incorporating activated carbon or ion exchange resin is that they would eventually need to be replaced to be effective in filtering out PFAS and require additional maintenance and operation cost. Thus, certain plants would be a more effective option. Non-physical BMPs that will work in conjunction with the physical BMPs could be implementation of regulations on the littering of debris and items that may contain PFAS, or investing in community organizations that help reduce the spread of PFAS items through community cleanups. The combination of physical and non-physical BMPs aimed at reducing PFAS transport into the environment, in addition to reducing other pollutant spread, would be a great option due to its preventative measures that also reduce PFAS exposure from other sources. The second solution is targeted at bodies of water that may be exposed to PFAS. In a recent research paper titled Plant Uptake of Perfluoroalkyl Substances in Freshwater Environments, conducted primarily in Dongzulong and Xiaoqing rivers in China with high PFAS concentrations, it was found that floating plants were very effective in absorbing PFAS from contaminated sources due to their high uptake capacity and large proliferation rate, and could eventually be used for remediation of PFAS. My proposed solution would be introducing floating plants into freshwater bodies such as rivers and portions of reservoirs to be able to absorb PFAS and ultimately reduce the PFAS exposure within the environment. This solution would contribute greatly to providing more greener space to many of the modified river and water bodies. As a more natural solution, the plants will require less operations and maintenance costs and only require a few routine inspections. While there may be additional considerations such as ensuring the floating plant species introduced is not harmful and invasive to the local ecosystem, the floating plants would provide a more natural visual aesthetic while performing constant remediation at low cost economically and socially. Overall, I believe the two solutions of BMP implementation and floating plant species placement would play effective roles in remediation of the recent PFAS issue that is harming the Southern California region. However, with just a few adjustments and consideration of differing ecosystems and other environmental factors, these solutions will be able to perform efficient remediation in many different regions of the world. Thank you for your time.